Now we are going to see about the Davison-Germer experiment. And before we go to the Davison-Germer experiment, we know about the de Broglie concept. So as per the de Broglie concept, if you are taking the any particles, it will acting as a wave when under such conditions. So those particles it will acting as a wave means electrons, neutrons or alpha particle. So if you are taking electrons, so in a negative nature, then proton it will having the positive nature, then it is an alpha particle. So electron, proton and alpha particle it will in the particle nature, then under such conditions it will acting as a wave nature. So wave nature is nothing but light nature. So electron, proton and alpha particle, so it is in a particle nature. Under such conditions all the particles it will possessing the wave nature. So this is the major concept of de Broglie, which is proved by the Davison-Germer experiment. So Davison-Germer experiment is nothing but, so it is mainly used to prove the de Broglie concept, that is nothing but a dual nature of matter waves. What is meant by dual nature? So a particle it will having the some of the time particle nature, the another some of time it will become as a wave. So some of the time it will in the particle nature, some of the time it will in the wave nature. So this is the dual nature which is said by the de Broglie, but which is proved by the Davison-Germer experiment. Here what is the major concept means, when the electrons are undergoing the diffraction, so when the electrons are getting by when the electrons are illuminated by the some of the crystals, it will undergoing the diffraction. So first of all we know about the diffraction. What is mean by diffraction? So diffraction is nothing but, so bending of light or sound, so bending of light or sound when hitting on the edge of the obstacle. So diffraction is nothing but bending of the light or sound when hitting on the edge of the obstacle. So in Davison-Germer experiment, which is used to prove the de Broglie concept, so which is nothing but a dual nature of the particles. So from the Davison-Germer experiment, the major concept is when the electron are hitting by the some of the crystals, it will undergoing the diffraction. So first of all we know about the diffraction. What is mean by diffraction? So diffraction is nothing but the bending of light or sound when hitting on the edge of the obstacle is known as the diffraction. The major concept of diffraction is what light we are using in the diffraction, the wavelength of light what we are going to use in the diffraction, which is equal to the interdistance of atomic layers. So interdistance of atomic layers. So this is the major concept of diffraction. So on this condition, in this condition only we are getting the diffraction. So what means the wavelength of light what we are going to use in the diffraction, which is equal to, that means the wavelength of light which is exactly equal to the interatomic distance of the crystals. So suppose if we are taking the visible light, the wavelength of light is 4000 Armstrong. So the wavelength of visible light is approximately 4000 Armstrong. Suppose the interdistance of atomic layer should lie in the range of 1 Armstrong. So there is the difference of 4000. So if you are taking the visible light, the wavelength of light is 4000 Armstrong, but in crystals the interatomic distance between the one atom to another atom should lie in the range of 1 Armstrong. 1 Armstrong is nothing but 10 power of minus 10 meter. 10 power of minus 10 meter. Here 4000 Armstrong, here 1 Armstrong. Suppose for getting the diffraction, suppose we can use the visible light means we didn't get the diffraction. Why? Because for condition if we want to obtain the diffraction means the major condition is the wavelength of light what we are going to use, which is exactly equal to the interatomic distance in the crystals. Suppose if you are taking the visible light, the wavelength range should lie in the 4000 Armstrong, but in crystals the distance between the two atoms should lie in the range of 1 Armstrong, which is nothing but a 10 power of minus 10 meter. So here 1 Armstrong, here 4000 Armstrong. So 4000, here the difference is 4000. So in majorly visible light cannot be used in the crystals. Why? Because the difference is 4000. So in the 4000 difference எனக்கு அதிகமா இருக்குறதுனால நம்ம என்ன சார் பண்றோம் அப்படினா, we cannot use the visible light for the diffraction obtained for the crystals. So if you want to obtain the diffraction from the crystals, we cannot use the visible light. ஒரு crystal இருந்து உங்களுக்கு diffraction நடக்கணும் அப்படினா we cannot use the visible light. Visible light நம்ம யூஸ் பண்ண கூடாது. அப்ப நம்ம யார் சார் நம்ம யூஸ் பண்றோம் அப்படினா, there are the two particles, there are the two light waves. So one is the X-ray One is a X-ray, the another one is a electron beam. Instead of visible light, we can use the two light source. One is the X-ray, another one is a electron beam. The wavelength range of X-rays you already know. So 0.1 Armstrong to 10 Armstrong. The wavelength of X-ray is would lie in between the 0.1 Armstrong to 10 Armstrong. So which is more or less equal to the interatomic distance of the crystals. Another is the electron beam. So how we are going to find the wavelength of X-rays? So electron in the particle nature. So this is the X-ray. So X-ray having the wavelength range of 0.1 Armstrong to 10 Armstrong. So which is we can use in the diffraction. Instead of visible light, we can use the X-rays. Why? Because visible light having the wavelength of 4000 Armstrong, but X-ray having the wavelength range of 0.1 Armstrong into 10 Armstrong, which is exactly equal to or more or less comparable equal to the interatomic distance between the crystals. So how we are going to calculate the wavelength of the electron beam? I hope you already know electron is a beam. So by de Broglie concept, in particle under such conditions it will possessing the wave nature. So wave nature is nothing but, so those particles or those light it will undergoing the diffraction, it will exhibiting the wave nature of this particle. So electron அப்படின்றது ஒரு particle, when it undergoing the diffraction it will exhibiting the wave nature. So now how we are going to calculate the wavelength of the electron beam? So by de Broglie formula, so lambda is equal to 12.27 Armstrong by root V. Here the V is the accelerating voltage of the electrons. When the electron is accelerated by the certain volts, we are obtaining the certain wavelength. So suppose when the electron is accelerated 100 volt means here root 100 is 10. So which is equal to 12.27 Armstrong by 10. So which is nothing but 1.227 Armstrong, which is equal to 1.2 Armstrong, which is comparable equal to interatomic distance of the crystals. So if you want to obtaining the diffraction, we cannot use the visible light, because condition for the diffraction, if we want to obtain the diffraction means what light we can use, the wavelength of light which is equal to the interatomic distance of the crystals. Here the interatomic distance of the crystals should lie in 1 Armstrong, but the wavelength of visible light is 4000 Armstrong. Here the difference is 4000, so we cannot obtain the diffraction while we are using the visible light. Suppose instead of visible light, we can use the two light beams. One is the X-ray, another one is the electron beam. I hope you already know about the wavelength of the X-ray, which should lie 0.1 Armstrong into 10 Armstrong, which is more comparable to the interatomic distance of the crystals. So instead of visible light, we can use the X-ray for obtaining the diffraction. The another source is electron beam. So I hope you already know about the electron is a particle, but the concept of the de Broglie, so those particles in the particle nature, it will possessing the wave nature in under such conditions. So here electron is a particle, the electron it will act as a wave in under such conditions. So now we are going to find the wavelength of the electron beam. So if we want to find the wavelength of electron beam, we can use the de Broglie wavelength. So de Broglie formula 12.27 Armstrong by root B. Here root V is nothing but how much of potential which is used to accelerate the electrons. How much potential we have to apply to accelerate the electron. Here root B. Suppose when the electron is accelerated, you are taking for example, when the electron is accelerated by 100 volts, here root 100 is 10, so 12.27 Armstrong by root 100 is 10, so 1.227 Armstrong is equal to 1.2 Armstrong. So 1.2 Armstrong is nothing but which is equal to the interatomic distance between the crystals. So if we want to obtain the diffraction from the crystals, we cannot use the visible light. Instead of visible light, we can use X-ray or electron beam. When the electron beam accelerated by the certain voltage, the wavelength obtained from the electron which is equal to the interatomic distance between the crystals. Okay. Now we are going to discuss about the Davison-Germer experiment. In the Davison-Germer experiment, we know about the de Broglie concept. What is meant by the de Broglie concepts? நம்ம என்ன de Broglie concept நம்ம என்ன தெரிஞ்சுக்கிறோம் அப்படி நீங்க பாத்தீங்க அப்படினா by de Broglie concept எந்த பார்ட்டிகிள் எல்லாம் பார்ட்டிகிளா இருக்கோ சில கண்டிஷன்ஸ்ல in some conditions it will acting as a wave. So I hope you already know about the some of the particles. நம்ம நார்மலா யூஸ் பண்றது electrons, protons, alpha particle. So it will placed in the அது வந்து என்ன சிச்சுவேஷன்ல இருக்குது அப்படினா particle நேச்சர்ல இருக்கு. Under such conditions it will acting as a wave nature. The wave nature is nothing but it is purely belongs to the light. So wave nature அப்படின்றது யாருக்கு சொந்தமானது அப்படினா லைட்டுக்கு சொந்தமானது. So from the Davison-Germer experiment ல நம்ம என்ன சார் சொல்றோம் அப்படினா இந்த particle nature wave nature இருக்குன்னு சொன்னது de Broglie, which is proved by the Davison-Germer experiment. So de Broglie concept. So de Broglie வந்து என்ன சொன்னார் அப்படினா இந்த particle natureல இருக்கிற objects எல்லாமே it will possessing the wave nature which is said by the de Broglie but experimentally which is proved by the Davison-Germer. So by the Davison-Germer experiment, which is nothing but when the accelerating electrons are hit by the nickel crystals, it will undergoing the diffraction. When the accelerated electron falling on the crystals, it will undergoing the diffraction. So this is the major concept involved in the Davison-Germer experiment. Or accelerate ஆகக்கூடிய electron ஒரு crystal மேல படுறப்ப it will undergoing the diffraction. So first of all we know about the diffraction. What is meant by diffraction? So diffraction is nothing but bending of light or sound when hitting on the edge of the obstacle. Or obstacle ஓட edgeல படுறப்ப when the light or sound is bend ஆகி போனுச்சு அப்படினா அதுக்கு பேர் நம்ம என்னன்னு சொல்றோம் அப்படினா diffraction. I hope you already know about the comparison of diffraction of the light is less when compared to the diffraction of sound. நல்லா ஞாபகம் வச்சுக்கணும். Diffraction of sound is maximum and compared to the diffraction of light. Suppose when we are standing inside the room, we are conveying some messages, we are speaking to the students or whatever it will be, the loudness will be here those who are in the outside the room. நம்ம பேசுறப்ப நமக்கு என்ன சார் ஆகும், நம்ம ரூமுக்குள்ள இருந்து பேசுறப்ப வெளிய இருக்கிறவங்களுக்கு கேட்கும். In same time those light are glow inside the room. எந்த லைட் எல்லாம் ரூமுக்குள்ள வந்து நல்லா glow ஆகுதோ அதோட வெளிச்சம் வந்து வெளிய போகாது. Why? Because of diffraction of sound is maximum than compared to the diffraction of light அப்படினு நம்ம சொல்றோம். diffraction வந்து யாருக்கு அதிகம் அப்படினா சவுண்டுக்கு தான் அதிகம், லைட்டுக்கு தான் கம்மி. Here diffraction, bending of light or sound. Suppose if we want to obtain the diffraction, என்ன necessary condition அப்படினா so நம்ம யூஸ் பண்ணக்கூடிய லைட்டோட wavelength-உம் நம்ம கிறிஸ்டல்ல ரெண்டு ஆட்டம்க்கு நடுவுல இருக்கிற டிஸ்டன்ஸும் ஈக்குவலா இருக்கும். So the wavelength of light which is exactly equal to the distance between the two atoms in the crystals what we are going to select. நம்ம என்ன crystal எடுத்துக்கறோமோ அது. So ஒரு crystal நீங்க பாத்தீங்க அப்படினா காமனா ஒரு crystalல the distance between the two atoms it should lie in the range of 1 Armstrong. 1 Armstrong is nothing but 10 power minus 10 meter. Here the wavelength of visible light is 4000 Armstrong. Here 4000 Armstrong இருக்கு, இங்க 1 Armstrong இருக்கு, டிஃபரண்ட் வந்து 4000 இருக்கு. So அதனால diffraction pattern இதுல work ஆகாது, நடக்காது. We cannot be obtained by this process. நம்மளால வந்து diffraction obtain பண்ண முடியாது. Why? Because இங்க 4000 இங்க 1. இந்த diffraction நடக்கணும் அப்படினா இது ரெண்டோட வேல்யூ more or less ஈக்குவலா இருக்கணும். So அப்ப நம்ம என்ன சார் பண்றோம் அப்படினா if we want to obtain the diffraction from the crystals, we can move to the another source. அப்ப visible light நம்மளால யூஸ் பண்ண முடியாது. We cannot use the visible light. So instead of visible light நம்ம என்ன சோர்ஸ் நம்ம யூஸ் பண்ணலாம் அப்படின்றப்ப we can identify two sources for obtaining the diffraction from the crystals. So crystal ல இருந்து நீங்க diffraction obtain பண்ணனும் அப்படினா we have the two sources. What are the two sources? One is the X-rays, another one is a electron beam. What are the two sources means? One is the X-ray, another one is a electron beam. So உங்களுக்கு ஏற்கனவே தெரியும் the wavelength of X-ray should lie in between the 0.1 Armstrong into 10 Armstrong. So more comparable to equal to the distance between the two atoms in the crystals. So X-ray நம்ம யூஸ் பண்ணலாம். So another method இன்னொரு source யார் சார் அப்படினா electron beam. Actually I hope you already know electron is a particle nature. Now we are going to find the wavelength of the electron. So electron is a particle nature. Wavelength is belongs to the wave. இது வந்து particle. நம்ம இப்போ வந்து wavelength of electron கண்டுபிடிக்கிறப்ப wavelength is nothing but wave of the particle. So அப்போ வந்து எனக்கு என்ன சார்னா electron is a particle. If we want to calculate the wavelength of the electron beam, we can use the de Broglie formula. So what is the de Broglie formula? 12.27 Armstrong by root V. When the electron is accelerated by 100 volt, by this formula root 100 is 10, so 12.27 Armstrong by 10, so we are getting the 1.227 Armstrong, so by rounding off 1.2 Armstrong. So X-ray electron beam ஒரு 100 volt கொடுக்கறப்ப அதோட wavelength by de Broglie formula we can obtain 1.2 Armstrong. In the crystals the distance between the two atoms is 1 Armstrong. So more comparable ரெண்டுமே ஈக்குவலா இருக்கிறதுனால by using an electron beam we can obtain the diffraction from the crystals. Okay, so now we are going to discuss about the experimental setup used in the Davison-Germer experiment. The low tension battery is connected with the filament. In filament it will offering the high resistance. So due to the high resistance all the current passing through the filament is converted into heat energy. So by the heat energy of the filament or thermionic emission. So by the heat energy or thermionic emission, the filament it will losing the electrons. So in the filament losing the electrons, the direction of the electrons are indicated by the dotted lines. So this is nothing but so this is the slit which is used to focus the electron which is used to focus the electron into narrow beam. So narrow beam is nothing but to pass the electron beam in a thin slit. So this is the aluminum cylinder. So this is the aluminum cylinder which is used to focus the electrons. So aluminum cylinder is nothing but just you think that a hollow cylinder. So hollow cylinder is nothing but which is considered as a open pipe. This is the aluminum cylinder. So which is assumed to be the open pipe or open pipe mari assume panikano. So which is connected with the high tension battery. So this is the instant beam. So this is the instant beam which is nothing but a narrow slit of electrons. So this is the scattered beam. So this is the scattered beam of electrons. This is the nickel crystal. So this is the electron detector. So which is the electron detector which is movable one. So this is Davison Germer experimental setup. முதல்ல நம்ம என்ன பண்றோம் அப்படினா low tension battery which is connected to the filament. So the filament is nothing but it will offering the high resistance. Due to the high resistance இது வழியா போகக்கூடிய எல்லா current energy which is converted into heat energy. Full-ஆவே heat energy மாறிடும். So dual nature oda beginning la நம்ம என்ன பண்ணிரோம் அப்படினா there are the four types of emission. So என்ன emissions are அப்படினு பார்க்கறப்ப அதுல one of the type வந்து எனக்கு என்னன்னா thermionic emission. So thermionic emission is nothing but the high heat energy la இருக்கக்கூடிய ஒரு filament it will lose the electron means that is said to be thermionic emission. So இந்த இடத்துல filament இதோட high resistance இது high resistance ஆ இருக்கிறதுனால இது வழியா போகக்கூடிய current energy the heat energy மாத்திக்குது. So due to the high heat energy of the filament it will losing the sum of the electron. This is commonly known as the thermionic emission. So this is the slit. The outcoming electron ஒரு சின்ன slit ஒரு சின்ன லைனை நமக்கு focus பண்ணி தரும். So இது வந்து aluminum cylinder which is connected to the high tension battery. இந்த aluminum cylinder நீங்க எதுமே ஒண்ணுமில்ல hollow cylinder. So hollow cylinder அப்படின்றது நீங்க ஒண்ணுமில்ல ஒரு open pipe மாதிரி நம்ம தண்ணி போற பைப்ல ரெண்டு ஓபனா இருக்கும் இல்லையா அது மாதிரி ஒரு open pipe assume பண்ணிக்கீங்க. So இந்த electron beam வந்து இந்த open pipe குள்ள உள்ள inside which is connected with the high tension battery. So what is the necessity why we can use the high tension battery? நம்ம ஏன் அது வந்து நம்ம high tension battery அப்படி நம்ம சொல்றோம் அப்படினா இந்த electron are emitted from the low tension battery. So இங்க வந்து நான் என்ன சார் பண்றேன் அப்படினா high tensionல பாசிட்டிவ் டெர்மினல் கொடுத்திருக்கேன். இப்போ high tension அப்படினா if you can apply for example 10000 volt. இங்க 10000 volt நம்ம கொடுக்கிறோம். So this is the positive potential which is connected with the aluminum cylinder. So it will offering the more attractive force. இது வந்து பாசிட்டிவ் இது வந்து எலக்ட்ரான் நெகட்டிவ் it will offering the more attractive force then that means electron it will accelerated more faster. electron என்ன சார் ஆகும் அப்படினா ரொம்ப வேகமா accelerate ஆக செய்யும். The total setup is known by the electron gun. So இத நம்ம என்னன்னு சொல்றோம் அப்படினா electron gun அப்படி நம்ம சொல்றோம். So this is the instant beam, this is the nickel crystal. When the electron are instant by the crystal or it will undergoing the diffraction. So this is the scattered beam which is focused by the electron detector which is movable one. The electron detector எப்படி இருக்கும் அப்படினா ஈஸியா நம்ம மூவபிளா இருக்கும். So theta is the angle between the instant beam and the scattered beam. So from the experimental values நம்ம என்ன சார் பண்றோம் அப்படினா if you are applying the particular voltage and when the electron is accelerated we can calculate the different angles. நீங்க ஒரு particular voltage கொடுத்து நீங்க அப்ளை பண்றப்ப we can calculate எந்த இடத்துல we can apply the maximum intensity எந்த இடத்துல எவ்வளவு ஆங்கிள்ல எனக்கு maximum intensity கிடைக்குது அப்படினு சொல்லிட்டு we can analyze by using an electron detector. இந்த theta ஓட value we can vary. Why? Because electron detector is movable one. electron detector வந்து not a fixed one. இது வந்து fixed one கிடையாது. It is a movable one. So due to the movable electron detector we can changing the angle between the instant beam and the scattered beam at what angle we can obtain the maximum intensity. So this is the concept what we are going to find. நம்ம என்னத்தை கண்டுபிடிக்க போறோம் அப்படினா ஒரு particular voltage நீங்க கொடுக்குறீங்க electron accelerate பண்ணிட்டீங்க when it illuminated by the nickel crystal when it fall over the nickel crystal it will undergoing the diffraction. So diffraction அப்படின்றது electron அப்படின்றது particle nature. By the diffraction instant beam is a electron nature here. Scattered beam is a diffraction means wave nature. So at what angle we can obtain the maximum intensity, that means maximum diffraction. So அத நம்ம வந்து கண்டுபிடிக்க போறோம். So theta is the angle between the scattered beam and the instant beam. Here instant beam is a electron particle nature, scattered beam is a diffraction wave nature அப்படி நம்ம சொல்றோம். From the experimental setup we can experiment number 9, we take a lot of reading, then we draw the graph between the angle and the intensity. So intensity is nothing but the scattered beam. So theta அப்படின்றது the angle between the incident beam and the scattered beam. So from this graph, when the electron is accelerated by 54 volt, electron வந்து நான் எப்ப 54 volt கொடுத்து நான் accelerate பண்றனோ அப்ப we can obtain the maximum intensity at an angle of 50 degree. So the 50 degree is nothing but the angle between the incident beam and the scattered beam. When the angle between the incident beam and the scattered beam is 50 degree, at the time the electron are accelerated by the 54 volt, then at the time only we can obtain the maximum intensity. Sir, how we are going to obtain the maximum intensity? At what reasons we are obtaining the maximum intensity is nothing but இந்த 50 டிகிரியில் 54 வோல்ட் கொடுக்குறப்ப we are obtaining the maximum intensity அப்படின்னா due to what is nothing but due to the constructive interference. கன்ஸ்ட்ரக்டிவ் இன்டர்ஃபரன்ஸ் அப்படின்ற ஒரு காரணத்தினால எலக்ட்ரானை 54 வோல்ட் கொடுத்து நான் ஆக்சலேட் பண்ணுறப்ப 50 டிகிரியில் we can obtain the maximum intensity. சரி, ஓகே. By de Broglie formula, so lambda is equal to 12.27 Armstrong by root V. So this is the common formula. So de Broglie wavelength of electron. So here root V. So V is the how much voltage we can apply. Here the applied voltage is 54 volt. So 12.27 Armstrong by root 54, so which is equal to 1.67 Armstrong. So by this experiment, the wavelength of electron which is calculated 1.67 experiment. So இந்த நிக்கல் கிறிஸ்டல் இருந்து நம்ம எவ்வளோ சார் கால்குலேட் பண்ணுறோம் அப்படின்னா the wavelength of electron 1. எனக்கு எவ்வளோ சார் அப்படின்னா 65 ஆம்ஸ்ட்ராங் கண்டுபிடிக்கிறோம். So this is the wavelength of the electron 1.67 experiment from this formula. So this is the experimental value. So experimental value 1.67 Armstrong. So இது வந்து இந்த ஃபார்முலாவில் 1.67 Armstrong கிடைக்குது. So from that we conclude Davison-Germer experiment which is used to prove the de Broglie concept. So what is the de Broglie concept? When the electrons are particle in nature, it will having the wave nature also. This is the major concept of dual nature. So involving இங்க வந்து நம்ம என்ன சார் சொல்றோம் அப்படின்னா இது வந்து wavelength 1.67 ஆம்ஸ்ட்ராங் வந்து எலக்ட்ரானுக்கு கிடைக்குது. நம்ம இந்த ஃபார்முலாவில் இது வந்து எக்ஸ்பெரிமெண்டல்ல 1.65 ஆம்ஸ்ட்ராங் கிடைக்குது. எதில் சார் அப்படின்னா டேவிசன்-ஜெர்மர்ல எக்ஸ்பெரிமெண்டல்ல we can obtain 1.65 ஆம்ஸ்ட்ராங். From this formula we can obtain the wavelength of electron 1.67 ஆம்ஸ்ட்ராங். ஸோ ரெண்டுமே சிமிலராக இருக்கிறதுனால டேவிசன்-ஜெர்மர் எக்ஸ்பெரிமெண்ட் இந்த de Broglie கான்செப்டை ப்ரூவ் பண்ணிட்டாங்க.